Okay, so welcome back to my new video on horizontal pod autoscaler. Okay, so for short, you call it HPA. And this Kubernetes object automatically updates a workload resources such as the deployment or the stateful set with the aim of automatically scaling the workload to match demand. So there's this kind of demand and supply scenario here. So horizontal auto scaling, pod auto scaling means that the response to increased load is to deploy more pods. So let's say you have one pod and then there's an increased utilization of your CPU. You might want to scale it on the fly. Okay, so that is the idea. And this is very different from the vertical scaling. And in Kubernetes, if you say vertical scaling, it means that you are assigning more resources, such as the memory or the CPU, to your pods that are already running. So horizontal auto scaling is when you are trying to scale more instances of your pod, whilst the vertical is adding more resources like the memory or the CPU to your running pod. And if the workload decreases, on your application, then the number of pod is above the configured minimum. Let's say initially you set your replica sets to be 1. So if the pod or the load decreases or increases, you might want to reconfigure this scaling process. So the horizontal pod autoscaler instructs the workload resource, that is the deployment or the stateful set or whatever resource it is, to scale back down. That is if the load decreases. Okay, so as the load increases, you might want to increase more instances of your pod. So in Kubernetes, this is the command. You type kubectl autoscale deployment, and then the name of the deployment, and then you specify that you want to scale if the CPU percentage is 50% or more, and those instances or those pods should scale in between 1 to 10. Okay, so that is the minimum, and the maximum pod should be around 1 to 10. Okay, so if you look at the diagram below, before horizontal pod autoscaler, you have one pod, just one pod. And if the load increases, you want to create more instances of your pods. So that's why you see 3 pods in this diagram. Okay, as well as this diagram, you are increasing the replica sets from 1 to n, depending on what you set, the threshold that you set as the minimum and then the maximum. So this is another interesting part. Once you configure this HPA, it's supposed to be in charge of checking the metrics and then scaling your replica sets up and down accordingly. So by default, HPA checks these metrics every 15 seconds. So it keeps monitoring your clusters to check which of your pods needs to be increased or decreased based on the workload. So most application workloads have a daily, weekly, and seasonal rhythms driven by the user activity. So if you think about it, let's say peak hours for enterprise productivity applications are mid-morning and then mid-afternoon in a given time zone when employees are at their desks, while they are close to idle on weekends and on holidays. Okay. And you can also think about a scenario where there are seasonal traffic patterns online on online retail shopping, like on Black Fridays or Mother's Day or Father's Day. During those seasons, there's going to be a lot of traffic on your application. So you, as the admin or the developer, you have to make sure that you come in before this day so that you can horizontally auto scale your application so that you can meet the demands on those special days. So other increases in activity may also result from a one-time event, like an approaching hurricane drawing residents to news websites and portals. So those events can also increase CPU or resource utilizations on your application. So it's a good practice. You note some of these things on your calendar. Let's say there's going to be an election, and you are using electronic application. Definitely millions of people are going to be visiting your application to vote. So in those scenarios, you might want to horizontally scale your application so that you can meet those demands. Okay. And then administrators of application infrastructure must always prepare their system to provision capacity within seconds in order to respond to both predictable and unexpected changes in their activity. And remember also to make sure that you remove these capacities when they are no longer needed. And that is where auto scaling comes in. And it's also good to automate the process of adding and removing capacity as the workload varies, which would otherwise be manual, so that you prevent unnecessary cost. Okay. So that is basically the idea. So if you look at these two diagrams, you can see Monday to Sunday, you see the time series of your cluster utilization. So you can see some peaks. So Tuesday, Wednesday, and then it drops as you get to the weekends. It starts rising from Monday and to Thursday, and on Friday, Saturday, Sunday, the utilization drops. So in those days, you expect that your HPA will drop the instances. Once it's during the weekdays, then it will increase the utilization, or the more, it will add more ports or more instances. And then if you look at the morning peaks, it goes up. And then during lunch breaks, the application also utilization goes down. And then afternoon peaks, it picks up again and drops after working hours. Okay, so that is basically the idea of horizontal pod auto scaling. So let's jump right into an example. Let me switch to, okay, so I'm in the IntelliJ IDE, and then we have a Docker file, which is making use of the PHP5 image. And then we copying this index.php file to this path. And then we running read and execute on this index.php, and then we are running this PHP file. Okay, and the content of the PHP file is this. We're creating a variable x and assigning this value, and then we looping from 0 to, I think, 1 million. And then we keep incrementing the iterator. And then we're taking the square root and then adding it back to x, and then echoing OK. Okay, so basically that is the idea. Okay, and then what else? I think the HPA.yaml file also contains two things. It's a deployment as well as a service. Okay, so basically we have one replica set, and then this is the name of the image, and then this is the image. Okay, PHP-Apache on my Docker username, and then this is the version 0.1.1. Okay, it's running on container 80, and it has resources of, it's requesting CPU of 200, and then the limit is of 500 CPU. Okay, and then the service is also listening on 80, and then it's selecting this name. Okay, and then it has a service name of PHP Apache. Okay, so basically that is it. We have a service as well as a deployment. Okay, so I think that is all to it. So let's jump into my terminal so we can run this file. Okay, so I'm in the terminal and in the directory. What I'm going to do is I'm going to create, I already have the image that I already pushed to Docker Hub. So, but I'm still going to do it. So it's Docker build PHP-Apache, and then enter. Then once I do that, I can say clear. I'm going to say Docker images. Okay, so this is the Docker image. Okay, this is the Docker image. I created it like 43 minutes ago, but I'm going to just push it to Docker Hub, Docker push, and then it's the same version anyway, 0.1.1. You see, the layer already exists, so you can try it at home. If you need a code, I'm going to leave it in the description box. So I think that is it. So what I can do now is let's check our notes, get notes. So I have two Kubernetes nodes running. But what I'm going to do is kubectl apply -f hpa.yaml. So as you can see, we've created a deployment called PHP Apache, and then a service called PHP-Apache. So I'm going to say kubectl get all wide. Okay, so as you can see, these are the ports that are currently running. Okay, and then we have a service also running, and then we have two deployments also running. You can see the image we're using, and then we have two replica sets. Okay, we have two of them, and I think I already have horizontal autoscaling, so I'm going to delete that for now. kubectl delete HPA, and then I'm going to delete also, and then we recreate it. Delete this. Then I'm going to recreate it. So I'm going to say kubectl apply -f HPA. So it's created one more time. kubectl get all. Okay, so as you can see, we only have one pod running, and then the same service, and then the same deployment. Okay, and then we have one replica set. Okay, so that is that. So what we want to do is we want to increase the load on this application. Okay, let's assume that it's a peak season and then there is more request on our application. What is it going to do? Is it going to crash, or what are we going to do? So we need to auto scale the application. So I'm going to increase the load on the application and see what can be done. But before we do that, we need to auto scale first. So the command is kubectl auto scale. What we are doing here is we want to auto scale the PHP Apache deployment, and then we want to set the threshold. Minimum is 2, and then maximum is 10. And then whenever the CPU utilization reaches 50% or more, we want to auto scale the deployment between port of 10, 2 to 10. Okay, so that is the idea. You can set it to any number that you want, but you have to be careful or cautious of your node resources. Okay, your node resources, you have to take that into consideration. Now I'm going to run that. So you see horizontal pod autoscaler is created. So what I'm going to do is I'm going to say kubectl get HPA. You see we have minimum of 2 and maximum of 10. And then the replica set is what? 1. Okay, and then the threshold is what? 50%. And currently, because we are not utilizing more resources, it's 0% at the moment. Okay. So let me run that command here, kubectl get HPA, and then we watch. The hyphen W means to watch. Okay, so let's put that aside. And then the next thing that I'm going to do is to increase the load. Okay, so I'm going to increase the load on the application and see what we get. So I'm going to run this command anyway, kubectl run. And what we are doing is that we are making use of the BusyBox image, and then we are running this forever loop. Okay, this is a forever loop, and it will keep calling this endpoint for until we cancel it or until we close it. Okay, so I'm gonna run that, and you should be seeing okay, meaning that each time it's making a wget on the endpoint, it will be making wget request on the endpoint for infinite number of times. Okay, so that will increase the load on our application. Okay, so let's assuming it was even an API endpoint, and then we are making request, get request, or post request. You see, that is a load, okay, on your application. So your application should be able to should have some shocks or resistance where it can scale no matter the request or on the resources of your application. So I'm going to run this. Okay, so as you can see, we have okay from the PHP file we created, index .php file. So if you notice here, as the OK keeps increasing, that means it's making a wget request on the endpoint for infinite number of times. Okay, so let's keep watching this. Then also I want to say kubectl get all. You see, currently we have the utilization getting about 152% out of 50%. So if you notice, our deployment increased to 4, and then the replica set also increased to 4. Okay, so if we check our port, you will notice that kubectl gets port. You will notice that when we started with just 1 port. Okay, so after the load increase, now you can see that we have how many more? 1, 2, 3, 4, 5, 6, 7 port, from 1 to 7 because of the load. Okay, so you see it dropped down from 152 to 48. Okay, so you can see the replica set is still 7. Okay, because the ports increase, so there's no need. That means that the utilization has to drop. Okay, because the number of replicas will cover up for the utilization. So that's why you see the number dropping after it got to 7 replica sets. Okay, so if you say kubectl get RC, ZRC, RS. Yeah, I think it's RS, replica set. You see, it's 7 of them. Okay, so currently you see the utilization is around 39% because now we have 7 replica sets. Okay, so that is the basic idea of horizontal auto scaling. Okay, so when the peak duration is over, you will see that these numbers will remain the same, but you as the developer should come in and then reduce the auto scaling threshold, okay, so that you don't incur unnecessary costs from your cloud provider. So I think that is all for this lesson. Thanks for watching. Don't forget to like the video and share and subscribe. And I'll see you in the next one.